Hello everyone, I am Suchit from Azure CXP team. Today we will take a look at the difference between IaaS, PaaS and SaaS. In a traditional on-premises setup, the customer has to manage the entire tech stack from actual hardware up to the application. In contrast, in a cloud environment, the service provider, for example, Microsoft in case of Azure Cloud, is responsible for managing some or most parts of the stack. This reduces management overhead and operating costs for the customer and improves scalability and agility. As explained in this slide, in IaaS or infrastructure as a service offering, the platform provider manages the physical location of the servers, hardware, networking, and storage. A cloud computing service provider such as Azure manages the infrastructure while you purchase, install, configure, and manage your own software, operating systems, middleware, and applications. Customer is expected to manage the operating system patching and updates, development tools like Visual Studio, database tools like SQL Server, etc., and the business application. IaaS quickly scales up and down with demand, letting you pay only for what you use. It helps you avoid the expense and complexity of buying and managing your own physical servers and other data center infrastructure. Take a closer look at Azure Virtual Machines, which is an infrastructure as a service offering on Microsoft Azure. Azure VM or virtual machines provide improved operational efficiency for your business and mission-critical workloads on both Windows and Linux environments. This is the overview blade that shows the essential details of the resource, such as resource group, status, location, operating system, size, public IP address, and DNS name associated with the VM. Let's quickly check the networking and disk blades. As we can see, these components are administered by Azure and can be easily accessed from the portal. We can use the VM as we would use any other on-premises server. For example, we can use it as a development machine or host web apps on the VM. In this demo, we will be connecting to my Windows VM via Azure Bastion host, which provides RDP or SSH connectivity directly from the Azure portal. As you can see, the VM can be set up as a database or web server, or can even be used for development environment. In fact, we can use the VM as we would use any other on-premises server. Moving over to PaaS or platform as a service, it not only includes infrastructure, servers, storage, and networking, but also middleware, development tools, business intelligence, BI services, database management systems, and more. You are responsible to manage the applications and services you develop. PaaS is designed to support the complete web application lifecycle, building, testing, deploying, managing, and updating. Platform as a service, PaaS, is a complete development and deployment environment in the cloud, with resources that enable you to deliver everything from simple cloud-based apps to sophisticated cloud-enabled enterprise applications. You purchase the resources you need from a cloud service provider on a pay-as-you-go basis and access them over a secure internet connection. PaaS allows you to avoid the expense and complexity of buying and managing software licenses, the underlying application infrastructure, and middleware, container orchestrators such as Kubernetes, or the development tools and other resources. Coming over to Azure App Services, which is a PaaS offering on Microsoft Azure, we can find a lot of useful information about our resource on the overview blade. For example, resource group, status, location, URL, app service plan name, FTPS host name, and deployment credentials. If we navigate to the site URL, notice the URL, which is the app name followed by azurewebsites.net domain, which is an indicator for Azure App Services resource. We can also find links to the Diagnose and Solve problem blade, useful for advanced troubleshooting, App Insights for viewing application telemetry data, and App Service Advisor, which provides recommendations for your app service. We can also navigate to Quick Start development guides for various tech stacks like ASP.NET, Python, Node, etc., or create deployment slots which help to deploy code in a pre-production environment before putting it in production. We also have access to a variety of CI/CD tools like GitHub, Bitbucket, Azure DevOps, etc., which we can see here. We can find the application specific settings in the configuration blade, or we can also set up third-party OAuth or AAD based authentication in the authentication blade, as we can see here. We can set up application backups here. Custom domains here, and TLS settings here. The networking blade provides access to available networking capabilities on Azure App Services, such as VNet integration, hybrid connection to connect to on-premises endpoint, Azure front door with WAF, CDN for distributed content delivery via POP servers across the globe, and access restrictions to lock down access to the web app. We also have access to vertical scaling via scale up and horizontal scaling via scale out blades. The Advanced Tools blade, or Kudu console, provides in-depth access to the underlying environment and is useful for diagnostic scenarios. We also have access to Azure Alerts to notify us in case of any issues, as well as Metrics blade to view the platform statistics, as we can see here. We can set up different logs in the App Service Logs blade for comprehensive troubleshooting. We also have access to the Process Explorer, which we can take a look to figure out which processes are currently running and what is the resource consumption for each one of them. Software as a service allows users to connect to and use cloud-based apps over the internet. Common examples are email, calendaring, and office tools such as Microsoft Office 365. SaaS provides a complete software solution which you purchase on a pay-as-you-go basis from a cloud service provider. You rent the use of an app for your organization, and your users connect to it over the internet, usually with a web browser. All of the underlying infrastructure, middleware, app software, and app data are located in the service provider's data center. The service provider manages the hardware and software, and with the appropriate service agreement, will ensure the availability and the security of the app and your data as well. SaaS allows your organization to get quickly up and running with an app at minimal upfront cost. Let's take a look at the general business use cases for all of them. Let's take an example of web-based email service such as Outlook, Hotmail, or Yahoo Mail. These are different forms of SaaS. With these services, you log into your account over the internet, often from a web browser or a mobile device. The email software, along with your messages and data, is located on the service provider's network, and you can access it from a web browser on any computer or internet connected device. The service provider ensures the security and cross-platform compatibility. With cloud-backed data, users can access their information from any internet-connected computer or mobile device without worrying about potential data loss in case of client device failure. For organizational use, you can rent productivity apps like email, collaboration and calendaring, and sophisticated business applications such as customer relationship management, CRM, enterprise resource planning, ERP, and document management on a pay-as-you-go pricing model. PAAS provides a framework that developers can build upon to develop or customize cloud-based applications. Similar to the way you create an Excel macro, PAAS lets developers create applications using built-in software components. Cloud features such as scalability, high availability, and multi-tenant capability are included, reducing the amount of coding that developers must do. Tools provided as a service with PaaS allow organizations to analyze and mine their data, finding insights and patterns, and predicting outcomes to improve forecasting, product design decisions, investment returns, and other business decisions. PaaS providers may offer other services that enhance applications such as workflow, directory, security, and scheduling. Moving on to IaaS. Teams can quickly set up and dismantle test and develop environments, bringing new applications to market faster in a quick and economical fashion. Hosting websites using IaaS can be less expensive than traditional web hosting. Organizations avoid the capital outlay for storage and complexity of storage management, which typically requires a skilled staff to manage data and meet legal and compliance requirements. IaaS is useful for handling unpredictable demand and steadily growing storage needs. It can also simplify planning and management of backup and recovery systems. IaaS provides all the infrastructure to support web apps, including storage, web, and application servers and networking resources. Organizations can quickly deploy web apps on IaaS and easily scale infrastructure up and down when demand for these apps is unpredictable. High performance computing HPC on supercomputers, computer grids, or computer clusters helps solve complex problems involving millions of variables or calculations. Examples include earthquake and protein folding simulations, climate and weather predictions, financial modeling, and evaluating product designs. Mining massive data sets to locate potentially valuable patterns, trends, and associations require a huge amount of processing power, which IaaS economically provides.